everyone, we're going to evaluate the improper integral or state that it diverges. We're going from 0 to infinity. We have e to the x divided by e to the 2x plus 3 dx. Okay, this is improper because we're dealing with infinite integration limit here. So we're going to be using this form. It's continuous on 0 to infinity. Let's go ahead and rewrite this real quick as the integral. Let's just write it as the limit using this form here. As t approaches infinity, and we have from 0 to t, e to the x power divided by, and let's rewrite this as e to the x power squared plus square root of 3 squared. Now we're going to have to integrate this. Oh, we have also dx here. Always forget that. So now let's integrate this with u substitution. We're going to let u equal e to the x power. So du equals e to the x power dx. So I'm just going to take this and evaluate it accordingly without the t and 0. So right now we're just working on this piece. So we're going to get the integral of e to the x dx equals du. So this is going to be 1 divided by u squared plus 3. All right, I'm just looking at this piece right now. All right, so now we're going to let u equal square root of 3t. And then when you integrate this, you're going to get 1 divided by square root of 3. And then we're going to have the integral of 1 divided by t squared plus 1. All right. Now t is going to equal u divided by square root of 3. So I can rewrite this now as u square root of 3. We're going to have our integral as e to the x power divided by e to the 2x plus 3 dx equals, you have this part, 1 divided by square root of 3. And now this has the form of inverse tan. And so that's going to be tan inverse of u divided by square root of 3. But our u is e to the x. So you're going to have e to the power of x divided by square root of 3. All right, so that's when you integrate. Now let's go on and evaluate it. So we're going to have the integral, we're taking the limit as t approaches infinity of 1 divided by square root of 3 inverse tan, or you can say arc tan. Let's do both. Arc tan of e to the x power divided by square root of 3. And this is going from 0 to t. Now this is going to give you, let's go ahead and pull this out, 1 divided by square root of 3. And then we have the limit as t approaches infinity of arc tan of e to the x, or e to the t, sorry, the t, divided by square root of 3 minus arc tan I'm used to writing the inverse tan. All right, so now that we have this part, we can evaluate it better. We have this 1 divided by square root of 3. As this goes off to infinity, here you're going to get pi divided by 2. And then minus pi divided by 6. When you substitute in 0, this is just pi divided by 6, by the way. You plug in 0, you're just going to get 0, so we don't really need to do that part. So when you simplify this, you're going to get 1 divided by square root of 3 times pi divided by 3. I just distribute it here. And that's going to give you pi square root of 3 divided by 9. Real quick here, I had pi divided by square root of 3 times 3, and all I did was rationalize the denominator. So that's just going to be pi square root of 3, and when you multiply these two, that's going to give you 3 times 3 is 9. So that's where I came up with that. So this is convergent. For that. Thank you. Have a nice day. Bye-bye.